Upgrading an electrical panel for an HVAC system expansion involves several key steps. Firstly, let's review the necessary materials. You'll need a 200 amp electrical panel, a 50 amp double pole breaker for the condenser, a 60 amp double pole breaker for the air handler or heat strips, 2-inch polyvinyl chloride conduit, 12/2 Romex wire for control circuits, 10 American wire gauge stranded copper wire for service conductors rated for 100 amps, and junction boxes. Now let's outline the installation procedure. 1. Prepare the existing panel. Identify the main breaker and turn off the power at the main disconnect. Verify there is no power flowing through the panel using a non-contact voltage tester. 2. Install the new panel. Mount the new 200 amp panel adjacent to the existing panel. Connect the neutral and ground bars to the corresponding bars in the existing panel. 3. Run the service conductors. Run 10 American wire gauge stranded copper wire from the meter to the main breaker of the new panel. Secure the wire in the conduit using clamps or staples. 4. Run the polyvinyl chloride conduit to the HVAC equipment. Run 2-inch polyvinyl chloride conduit from the new panel to the condenser and air handler. Use 90-degree bends to maintain proper wire clearance. 5. Install junction boxes. Install junction boxes at the connection points for the condenser and air handler. These will house the wire connections. 6. Pull the wire to the HVAC equipment. Pull the following wire through the conduit. 12/2 Romex for control circuits, which include black, red, white, and ground wires. Also pull 10 American wire gauge stranded copper wire for power, which include 2 black wires, 1 red wire, and 1 green or bare ground wire. 7. Connect the HVAC equipment. Make the electrical connections inside the junction boxes. Connect the black power wires to the line terminals of the breakers. Connect the red power wires to the load terminals of the breakers. Connect the green or bare ground wire to the ground bar. Connect the control wires to the appropriate terminals on the HVAC equipment. 8. Power up the system. Double check all connections. Turn on the main breaker and verify that the HVAC equipment is operating properly. Consider these other factors. Ensure that the electrical work is performed by a licensed electrician. Obtain any necessary permits from local authorities. Consider upgrading the insulation and ventilation in the attic or crawl space where the HVAC equipment is located to improve efficiency and prevent overheating. It is crucial to select the appropriate wire gauge for the service conductors based on the anticipated load and the distance from the meter to the panel. The National Electrical Code, or NEC, provides guidelines for wire sizing to ensure safety and prevent voltage drop. Use NEC Table 310.15. The 16 to determine the ampacity of conductors based on their insulation type and temperature rating. For example, a 10 American wire gauge copper wire with THHN insulation rated for 90 degrees Celsius has an ampacity of 35 amps in typical conditions. However, diluting factors may need to be applied based on the number of current carrying conductors in a raceway or conduit, as per NEC section 310.15. C1. This ensures that the wire can safely handle the load without overheating. When installing the 200 amp panel, proper grounding is essential for safety. Connect the grounding electrode conductor from the panel to a suitable grounding electrode system, such as a ground rod or a water pipe, as specified in NEC sections 250.50 and 250.52. The size of the grounding electrode conductor should be determined based on the size of the service entrance conductors according to NEC Table 250.66. This ensures that fault currents can safely return to the source, tripping the breaker and preventing electrical shock. For the polyvinyl chloride conduit installation, use appropriate fittings and connectors to ensure a secure and watertight seal. Polyvinyl chloride conduit is available in various sizes and thicknesses, so select the appropriate type based on the application and local codes. When bending polyvinyl chloride conduit, use a conduit bender to avoid kinking or damaging the conduit. Support the conduit at intervals specified by the NEC, typically every 3 feet, using appropriate straps or clamps. This prevents the conduit from sagging or becoming damaged over time. When pulling wires through the conduit, use a wire pulling lubricant to reduce friction and prevent damage to the insulation. Avoid pulling too many wires through a single conduit, as this can make it difficult to pull and can increase the risk of damage to the wires. Follow the fill requirements specified in NEC Chapter 9, Table 1. This ensures that there is sufficient space for heat dissipation and prevents overheating. When making electrical connections inside the junction boxes, use appropriate wire connectors such as wire nuts or terminal blocks to ensure a secure and reliable connection. Tighten the connectors to the proper torque to prevent loosening over time. Label each wire with its function to aid in future troubleshooting and maintenance. This makes it easier to identify the wires and ensures that they are connected correctly. When connecting the HVAC equipment, follow the manufacturer's instructions and local codes. Ensure that the equipment is properly grounded and that all connections are tight and secure. Use a multimeter to verify that the voltage and current are within the specified ranges. This ensures that the equipment is operating properly and that there are no electrical faults. After completing the installation, inspect the entire system to ensure that it is safe and compliant with all applicable codes and regulations. Verify that all connections are tight and secure and that there are no exposed wires or other hazards. Test the system to ensure that it is operating properly and that all components are functioning as intended. Keep detailed records of the installation, including wire sizes, breaker ratings, and other relevant information. This will be helpful for future maintenance and troubleshooting. When selecting breakers for the new panel, choose breakers that are specifically designed for use with HVAC equipment. These breakers are typically time delay breakers, which are designed to handle the high inrush currents that occur when HVAC equipment starts up. Using the wrong type of breaker can cause nuisance tripping, which can be frustrating and inconvenient. When connecting the control wires to the HVAC equipment, follow the manufacturer's wiring diagram. This diagram will show the correct terminals to connect the wires to. Connecting the wires to the wrong terminals can damage the equipment or prevent it from operating properly. When running the service conductors from the meter to the new panel, consider using a separate disconnect switch near the meter. This will allow you to disconnect the power to the panel without having to go inside the house. This can be useful for maintenance or in the event of an emergency. When mounting the new panel, ensure that it is securely attached to the wall. Use appropriate fasteners and mounting hardware to ensure that the panel will not come loose over time. Also, ensure that the panel is located in a dry and well-ventilated area. This will help to prevent corrosion and overheating. When running the polyvinyl chloride conduit, avoid running it through areas where it could be damaged by vehicles or other equipment. If you must run the conduit through such areas, protect it with a suitable cover or guard. When pulling the wires through the conduit, avoid using sharp objects that could damage the insulation. Use a wire pulling lubricant and pull the wires slowly and carefully. When making electrical connections, ensure that the wires are clean and free of corrosion. Use a wire brush or other suitable tool to clean the wires before making the connections. Also, ensure that the wires are properly stripped and that the insulation is not damaged. When testing the system, use a multimeter to verify that the voltage is within the specified range. Also, check the current draw of the HVAC equipment to ensure that it is not exceeding the rated capacity. If the voltage or current is not within the specified range, troubleshoot the system to determine the cause. When upgrading an electrical panel for an HVAC system, it is essential to understand the relevant electrical codes and regulations. The National Electrical Code, or NEC, is the primary standard for electrical installations in the United States. It provides detailed requirements for wiring, grounding, overcurrent protection, and other aspects of electrical systems. Local codes and regulations may also apply, so it is important to check with your local authorities to ensure that your installation complies with all applicable requirements. One important aspect of electrical codes is the proper sizing of conductors. The NEC provides tables and guidelines for determining the appropriate wire gauge for different types of circuits and loads. The size of the conductor must be sufficient to carry the anticipated current without overheating or causing excessive voltage drop. Factors to consider include the ampacity of the conductor, the ambient temperature, and the number of current-carrying conductors in a raceway or cable. Another important aspect of electrical codes is proper grounding. Grounding is essential for safety, as it provides a path for fault currents to return to the source, tripping the breaker and preventing electrical shock. The NEC specifies requirements for grounding electrode systems, grounding conductors, and equipment grounding. The grounding system must be properly installed and maintained to ensure its effectiveness. Overcurrent protection is another critical aspect of electrical codes. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The NEC specifies requirements for the type and size of overcurrent protection devices that must be used in different applications. The overcurrent protection device must be properly sized to protect the circuit without causing nuisance stripping. In addition to the NEC, there may be other relevant codes and regulations that apply to HVAC systems. For example, the International Mechanical Code, or IMC, provides requirements for the installation and maintenance of mechanical systems, including HVAC systems. The IMC covers aspects such as ventilation, ductwork, and equipment clearances. It is important to consult both the NEC and the IMC to ensure that your HVAC system is installed in accordance with all applicable requirements. When working with electrical systems, it is always important to prioritize safety. Electrical shock can be deadly, so it is essential to take precautions to protect yourself from harm. Always turn off the power to the circuit before working on it. Use a non-contact voltage tester to verify that the power is off. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Never work on electrical systems in wet or damp conditions. If you are not comfortable working with electrical systems, hire a qualified electrician to do the work. Electrical work should only be performed by qualified and licensed professionals. Hiring a licensed electrician ensures that the work is done safely and in compliance with all applicable codes and regulations. A licensed electrician has the knowledge, skills, and experience to perform electrical work safely and effectively. They can also obtain any necessary permits and inspections. In addition to safety, there are other reasons to hire a licensed electrician. A licensed electrician can ensure that the electrical system is properly designed and installed to meet your needs. They can also troubleshoot and repair electrical problems quickly and efficiently. Hiring a licensed electrician can also protect you from liability. If you do electrical work yourself and someone is injured as a result, you could be held liable. However, if you hire a licensed electrician, they will typically carry insurance that will protect you from liability. When hiring a licensed electrician, be sure to check their credentials and references. Verify that they are licensed in your state and that they have a good reputation. Ask for references from past clients and check them carefully. Also, be sure to get a written estimate before the work begins. The estimate should include a detailed description of the work to be performed, the materials to be used, and the total cost. By taking these precautions, you can ensure that you are hiring a qualified and reputable electrician. In conclusion, upgrading an electrical panel for an HVAC system requires careful planning and execution. It is essential to follow all applicable codes and regulations and to prioritize safety. If you are not comfortable working with electrical systems, hire a qualified electrician to do the work. By taking these steps, you can ensure that your HVAC system is installed safely and efficiently. Always remember to double-check your work and test the system thoroughly after completing the installation. This will help to identify any potential problems and ensure that the system is operating properly. Also, be sure to keep detailed records of the installation, including wire sizes, breaker ratings, and other relevant information. This will be helpful for future maintenance and troubleshooting. By following these guidelines, you can successfully upgrade your electrical panel for your HVAC system and enjoy years of reliable and efficient operation.